Hi everyone, welcome to the third section of chapter 11. We're going to talk about how to find the probability when we have multiple events happening. When there's multiple things happening, the first thing you have to do is figure out if they are affecting each other or not. If one event has nothing to do with the other, then they are totally independent. And we'll explain that. And another one could be dependent. If one has an effect on the other, then they are dependent, and it really makes a difference. So let me show you what I mean by that. Let's say you roll a number cube and you spin a spinner. Okay, are those events dependent or independent? Rolling a number cube and spinning a spinner. Obviously, rolling a number cube has no effect on the spinner, and the spinner has no effect on the number cube. So those are completely independent events, and you can look at them separately. They don't affect one another. What about if I have pick a card out of a deck, and then I pick another card out of a deck? Are those dependent or independent? And actually, they are dependent, because after I have selected a card, the deck I'm selecting from has changed now. That card is no longer there, and so that affects the possibilities of my second choice. Those two acts are dependent, or at least the second one depends on the first. So those are dependent on one another. Let's see, look at this one. You select a coin at random from your pocket. You replace the coin, and then you select again. So is that dependent or independent? And hopefully you said that they are independent because I put the coin back. So my second choice was just the same as the first. The first one did not affect the second one because I returned the coin to my pocket. All right? Okay, so now we are going to look at, now that we have that groundwork, let's look at probability of multiple events. Let's say we want to find the probability of two events occurring, the probability of A and B, both together. So I want to find the probability of, I'm going to write this the way it is here, of A and B, two separate events happening together. What you do to do that is you take the probability of A and you multiply that times the probability of B. And that's how you find that probability. For instance, you're at a picnic and you're walking along the line, and there are 10 diet drinks and 5 regular drinks that you can select from. And there are 8 bags of fat-free chips and 12 bags of regular chips. If you grab a drink and a bag of chips completely at random, so you're blindfolded, okay, without looking, what's the probability that you get a diet drink and fat-free? So diet drink and fat-free chips. I'm going to refrain from talking about diet drinks and fat-free chips. I could say a lot, but I'll just refrain. Anyway, so we're going to look at the probability of a diet drink. So look at what we said earlier. There are 10 diet drinks and 5 regular drinks. So there's 10 out of 15 are diet, or 2 out of 3. That's this one. The probability of the fat-free chips, I need to look back at my list. There are 8 fat-free out of, and 12 regular. So that means that fat-free is 8 out of 20 total. Be careful, don't say 8 out of 12 because there's 12 regular. There's 20 bags of chips total. 8 of them are fat-free, 12 are regular. So it's 8 out of the 20, that's the probability of the fat-free chips. What you do is you multiply those. So 10 over 15 times 8 out of 20. Or you can obviously reduce and simplify, or you can just straight multiply them in your calculator. What you end up with is that equals 4 out of 15, or about 26.7% is that occurring naturally, blindfolded, picking them up blindly. Those were completely independent events. We wanted to find the probability of both of them occurring, so this was the and, so we just multiply the probability of one times the probability of another, and we've got it. What's the probability then that you get a regular drink and regular chips? Okay, if there's 10 out of 15 diet, can you figure out how many there are regular? And if 8 out of 20 were fat-free, can you figure out how many there were at a regular? And can you figure out now by random, you got regular chips, regular drink. What was the probability that that happened? So figure that out while I erase the board, and then I'll tell you what your answer should be. Okay, I hope you got 20%. 20% was the probability that you got regular for both of those. Okay? All right, mutually exclusive events. Mutually exclusive means that they exclude one another, so it can't happen. Their probability of both happening. Okay, so the probability of A and B occurring ends up being 0 because they're mutually exclusive. So let me give you some examples. You determine, are these mutually exclusive or not? So you roll a number cube. Is it possible for you to roll in one roll a 2 and a 3? You can't roll both a 2 and a 3, mutually exclusive. The probability of both of those occurring in your one roll is a big 0 because they're mutually exclusive. What about rolling an even number and a multiple of 3? Is that mutually exclusive? An even number and a multiple of 3. That's not mutually exclusive because there is an even number that's a multiple of 3. It would be 6. So the probability of that would be 1 out of 6. You have an even number and a multiple of 3. Okay? You roll a standard number cube. Now I want you to just see if they're mutually exclusive or not. You roll a standard number cube. Are these mutually exclusive? You roll an even number and a prime number. Is there an even prime number? Some of you automatically said no, and you're wrong because 2 is a prime number and it's even. So that's not mutually exclusive. 2 is a prime number and an even number. What about rolling an even number and a number less than 2? Are those mutually exclusive? Yes, because the only number less than 2 is 1 and it is not even. So that's mutually exclusive. Okay, so that's dealing with the probability of 2 things occurring, A and B. What if they don't both have to occur? We want the probability of A or B. Oh, this is different. So now I'm looking for the probability of A or B occurring. So here's how you do that. You do it, it's the same, if they're, yeah, okay, so the probability of A or B is this. It's the probability of A plus the probability of B minus the probability of A and B. Okay, this is going to make sense in a minute. If they are mutually exclusive, then it's just this part. But if they are not mutually exclusive, then you have to do this. So I'm going to show you what I mean by this in a second. First of all, let's look at it simply. You're in a high school, and at your high school, you can take 1 foreign language class each term, only 1. 37% take Spanish, so Spanish is about 37% of the high schoolers take that. About 15% of the students take French. What is the probability that a student chosen at random from the school is taking either Spanish or French? Spanish or French. 30% probability for Spanish, 15% for French. To find the probability that a student chosen at random is taking either Spanish or French, you add those up. So it's 37% plus 15%, 52% probability. 52% probability. You just add those two probabilities together. All right? Let's say, let me make sure you understand this. Let's say that they also offer a Mandarin, and 9% are taking Mandarin. Okay, MA, 9% are also taking Mandarin. So what's the probability that a student chosen at random in this high school is taking either Spanish or French or Mandarin? Spanish or French or Mandarin, what's the probability for that? So figure that out. You should have gotten 61% because you just add all those probabilities together. All right? That's how that works. Okay, now I'm going to show you what we mean by this and why I put that minus there part. This makes sense. What is this about? By the way, those foreign languages were mutually exclusive because the student's only allowed to take one. They can't take two, so one doesn't exclude the other, right? But let's say I have on a tray some shapes. Okay, I have just drawn on the board a tray with these different block shapes on it. This is, the letters represent what color they are. So this is a yellow triangle. There's an orange circle, a green circle, a red circle, a green square, a red circle, an orange square, and a green circle. I don't have colors, markers, but that will do. So I have all of these different shapes on the board, and I want to know, suppose that you reach into the dish and you select a token, one of these, at random. All right, what's the probability that the token is either round or green? Round or green. So we have round shapes. Looks like we have, let me see, 1, 2, 3, 4, 5, 6, 7. We have 9 shapes altogether. And it looks like we have 1, 2, 3, 4, 5 round shapes. And we have 1, 2, 3 green shapes, it looks like. So we have 5 out of 9 are round and 3 out of 9 are green. So if we just add those together, because they can be round or green, we would have 8 out of 9. But wait a minute, we have some that are both round and green, right? We have this one right here. Do you see that? So that one has to be subtracted out, and that's what this is all about. When you're finding a probability of either A or B, you don't want to count a possibility twice. So you only count the round or green, but don't count the green round ones twice. Don't count them once for being round and then again for being green. There's still only one token. That's why we subtract out the ones that are round and green, which is 2 of them right here. Right? 1, 2, 3, 4, 5 out of 9, and 1, 2, 3 that are green, minus the 2 out of 9 that are both round and green, and that would leave us 6 out of 9 equals 6 out of 9, and that's the probability. So 2 out of 3 possibilities that you would pick round or green. Does this kind of make sense now? Let's do one more, and then I think you'll have it. What's the probability from this same tray? Let's keep this same tray. What's the probability that you select a token at random and it is square or red? So it is square or red. Okay, figure that out. Look at it, figure out what's the probability that it is square or red, remembering to do this. And you should have got 5 out of 9. Okay? Don't count this red square twice. Okay? Let's do another one. What's the probability that it is green or square? Green or square? Okay, figure that out. That's also 5 out of 9. Don't count this green square twice. So count all the greens in the squares. 1, 2, 3, 4, 5 out of 9 without counting this one twice. Because if you count it twice, if you count all the green, then all the squares, then subtract the green squares, okay? See how that works? I hope you see how that works. That's what this section is all about. So the probability of compound events with either an and or an or, and the two different ways to find that out. And are events mutually exclusive, or are they dependent or independent? Being able to analyze those as well. So have fun with that, and I will see you next time when we learn more about probability. Bye for now.